we did a math modeling lab, even though we got a lower accuracy, we still did better because we elaborated on more points and helped the students understand more. And also, we got a worse grid. They literally used the smartboard grid.
And we had a very better teamwork and communication, and we gave more effort in our work than them.
Very better, right? So my name is Bari, Brown University physics graduate student, and I partner with Abraham Bari.
Literally had 153 scores, and also it's not our fault that you.
153.
Yeah, and also
53. Where did you get that calculation from?
I counted that. But anyways, also it's not our fault that you literally use a whiteboard. Like,
Okay,
No, you guys were the ones
advantage
with the
of using the
smartboard.
smartboard. And welcome to Measurement Lab, where our goal is to have an error less than 5%.
All right, but what are we actually measuring, first of all?
Aren't we measuring how many stickmans we can draw in less than 1 minute?
Yeah, stick man. So, yeah, we are measuring how many stick figures we could draw in less than 1 minute. So, we're going to keep it bare bones and just draw the stick figures this way, all right? So, you're going to be drawing them, and I'll just be timing it. But first of all, what are the steps to actually measuring one of these?
Isn't there 3 steps?
All right, but what are they?
I think the first one is hypothesis.
Okay, so that's like an educated guess, right? So we just abbreviate that with H not. And what's the second one?
Isn't in model?
Okay, yeah. So we're gonna model it with a bunch of smaller experiments, then average the data so we can apply it to the big experiment. And then
at
lastly,
the end, experiments.
Yeah, so we're just gonna actually draw the stick figures. So first of all, the hypothesis is just an educated guess, but a guess nonetheless. So how many stick figures do you think you could draw in 60 seconds?
60 seconds? I think at least 35.
All right, 3, 2, 1, go. All right, that was 1.78, which will round to 1.8.
Oh, or 1.8, yeah.
We round up. All right, 3, 2, 1, go. All right, that was 2.86, which will round to 2.9. All right, next, 3, 2, 1, go. Okay, that was 4.30 exactly, so 4.3. And next, 3, 2, 1, go. All right, that was 5.77, which will round to 5.8. And then finally, 5 stick figures, 3, 2, 1, go.
Oh my god, these are horrendous.
And wow, that was a pretty big jump. 8.85, 3, 4, 5, 6, 7, 8, 9, 10.
Seconds, it would be around here, and we're gonna travel all the way up here.
Oh, what was that noise? All right.
That one is 4.
No, we're trying to read it out to make it more hands-on.
And the next one is 4.3. So do you want to draw that one?
4. Oh yeah. Okay.
Do you want to draw that one?
Let's see. So that would be like right here, I think.
Yeah, and then you would move all the way up.
Let's see.
Yeah. Perfect.
Okay, great. Okay. And we're just gonna fix that up.
The next one is 5.8
All
seconds.
right. Let's see. That's like
Yeah.
Okay. And you can do the last one.
8.9 seconds. So closer to 9. So that's like literally right here. Then you go all the way up. Tell me when to stop. Here?
Yeah, I kind of travel towards the middle.
Here?
You should probably do it a little bit more right. Yeah. Which is unexpectedly short and
okay, maybe we could start from like here and then we could just
All right. And you can maybe just like wing the last part.
How is this gonna work?
Ignore the last part. Last punch.
Okay, ready?
All right, so I'll hold the ruler.
Ready?
Oh wait, I should probably drop my phone. Yeah, that can go there.
Ready?
Yep. Ready, Freddy, go. Okay, so basically, the thing about a best fit line is we can't use any of these points to find the slope. Instead, what we're going to do is we're going to try and find a point where the line meets up with a lattice point. So like where the grid meets up. So like for right over here, for example. Can you find one other point where...
different color, Isaac.
And,
okay, maybe let's use blue.
And I think a better thing to do would be to extrapolate it a little bit more, just so we could probably find a few more grid points. So I'll draw that right there, and I'll also draw that right there. Okay. All right.
Oh, there's one right here.
Oh, great. All right. Can you? Yeah. Okay. And let's see. So this one is
Both
at
of you go on that side. Okay.
all right. So this one is at 5 on the x, but what is it on the y?
I don't know. What would you round this to?
Well, I mean, it is a lattice point, so let's see. 3, 3 1/3. Oh, and also, it looks like someone erased this, so we'll just draw a stick figure. So,
And then x is time. Put time.
Yeah, I'll put
Yeah.
some. I'll put some.
all right. So our first point is
You said
uh,
3.5 and 5, so 5, comma.
3 1/3.
Oh
All
yeah,
right.
3 1/3.
And then you look at the second point.
One is 7.
And what's the
Okay.
y?
What would you say that is?
4 2/3, I think. All right. So now we just use the slope-intercept formula.
Come over here now. Okay.
So
The first, I'll write it down.
Yeah.
So the first point is 5 and then 3 1/3. Second one is
7 4 2/3. All right.
There you go.
So here's what we're gonna do. We're gonna use the formula slope is equal to the difference in the y divided by the difference in the x.
What was that? I forgot 1/3.
It was 1 1/3.
Okay. So
All right. So what's the difference between these two?
1 1/3.
All right. And what's the difference between these two?
2.
All right.
Oh my god.
Bruh, even the marker doesn't want you to do anything. So this is look like 4/6 or 2/3, which is about 0.667. This represents the number of stickmans that Aju was able to draw. I said stickman per second. So what do we multiply this by to get how many you can draw in a minute?
60 by 60 by.
All right, so let me think. 2/3 times 60. I think that's 40. So, all right, that's pretty close. You said your hypothesis
Was 35.
all right, and our model was 40. So then, finally, the only thing left to do is the actual experiment. So get ready, because we're not just going to be drawing 5 stickmen. We're going to be drawing somewhere around 40. So let's see how many you can actually
So
draw.
Isaac, you hold the camera and Aju draw it.
No, I'm going to be holding a stopwatch.
You holding the stopwatch and Aju draw it.
Yeah.
Okay, go ahead.
As many stickmen as you can in 60 seconds. Give me...
Okay, ready?
Wait, no. Give me 7 hours. Okay. 3, 2, 1, begin.
Show that, yeah. Faster, Aju.
Trying.
Oh, wait, no. Restart. Can you make them a little bit smaller? 40 can't fit if you draw them really big. Wait, okay.
Only, can you put only one time so that it looks good?
What? Yeah, this is just one time. All right. Wait. Cancel. All right. 3, 2, 1, start. Making good progress. Seems to be pretty on pace with her hypothesis.
Oh my god.
Right? 15 seconds left.
Abraham, keep your finger crossed. Hopefully they're gonna do worse than you. You did 10%.
3, 2, 1, and time.
Aju count.
Okay.
No, I'll count this.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25,
Bro's
26,
disabled.
27, 28, 29, 30, 31, 32, 33, 34, 35, 36.
Whoa, that's really close.
36.
Wait, bro is just real.
Unreal.
All right. So
Okay.
now
I think you're gonna beat Bro.
the last thing to do is to calculate the percent error. So that's just the difference between our model and our experiment. How much is that?
No, write the equation for public.
All right. So the percent error is the difference between the absolute value of the difference between our experiment and our measurement divided by the experiment times 100%. But the difference between the experiment and the model divided by the model. So what's the difference between our model and our experiment? Yeah, of course, times 100%. So what's the difference between these two?
4.
All right, and what was our prediction in the model?
35.
No, the
Sorry,
model.
40.
All right, and times 100%, it looks like that's 1 over 10 times 100%, which gives us a 10% error, which is the same exact one as our competitors
What?
got.
The first step is a hypothesis. So, Abraham, how many stick figures do you think you can draw in 1 minute?
I think I might do 35.
35. Okay, that is a good guess. Let's write it in the hypothesis column. Okay, and the next step for a scientific inquiry is a mathematical model. So let's do the model. 3, 2, 1, go. 4.25. Okay, go.
The tapping sound is crazy. Okay.
Okay, 11.3.
A lot. Kind of.
11.3 seconds.
29.
Okay. Okay, great job.
So this one would be 4. Oh, I gotta cross it out. This would be 4.3.
Okay, great. So we have the rounded times.
Yes. With these times, we're gonna put them on like these graphs,
Okay.
time graph, right?
Okay.
Okay, let's just start off by putting some numbers in the middle. So this would be 3. This would be 5. Okay, now our first time would be 4.3. Now we just put like these dots to represent that it was here. Now we put this big thing like a collision happened. Okay, now we have just 6 seconds. Okay.
Okay, let's try to get 2 exact points from the graph. So let's see, this point looks very nice. Okay, so good. We have 2 exact points from the graph, 2, 0.66 and 9.3, 3.3. Okay, so Abraham, do you want to calculate the slope between these 2 points?
We're gonna write the equation now. M equals y2 minus y1. Now we have to divide this and go to x's. The x's, okay, x2 minus x1.
Okay, great. And let's say that this is my x1.
Now we're gonna put 3.3 minus 0.66.
Okay.
So 9.3 minus x1, which is right here. Is 2.36. Oh no, it's on our.
So if we can do 0.36 stick figures a second, then how many stick figures can we do in a minute?
Yeah. You have to like multiply with 60.
Multiply by 60. Okay. So I have to multiply 0.36 by 60. Let me do that. And that gives me 22. Okay, so not bad. Not far off from our hypothesis, but we have to calculate the error. Okay, so the third step is experiment. And so Abraham is going to draw as many stick figures as he can in 1 minute.
Yeah.
Okay, so are you ready? I'm going to start the stopwatch. Okay, let's see. 1 minute on the clock. Ready?
I am so scared. Okay.
3, 2, 1, go.
They don't have to be so far away from each other.
Okay.
Aju, do you have a phone?
Yeah.
Okay.
Oh my god.
So when you edit it on iPhone,
Why
iMovie,
is the light
move it, make it faster.
Okay.
Oh wow.
Otherwise it will be boring. So do it quickly. The computer is in your room. You know, not your room, second floor. Your room, the first floor.
And 1 second, and
Oh.
we're done.
Oof.
We're done.
Wow.
All right, so let's see. Can you count?
Yeah. Let's count.
Okay.
2. Let's go quickly. Okay. 2, 4, 6.
No, just count one.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay,
Okay.
we made 20 stick
20,
mans.
which is very close.
Do this.
No. People.
Okay, action.
Okay, so our 3 measurements were first the initial hypothesis, which was 35 stick figures. Then the math model, which suggested 22 stick figures. And then our experiment, which was 20 stick figures. Okay. Now let's calculate the percent error between the math model and the experiment. So that's going to be the math model minus the experiment divided by the math model, okay, times 100%. So let's see what that is. So that's going to be 22 minus 20 over 22 times 100. So let's see. Okay, so that is 2 over 22.
Whoa.
No, 2 over
Oh my god.
2 over 22. Okay,
Just
much
right.
better. Okay. And
Just write
so our error is 9.1%. So it's not less than 5%, but it's pretty close. So we have gotten below 10% error, which is an achievement. So very good job.
Yes.